All right, here we have a problem. When an integer a is divided by 7, the remainder is 4. So what does that tell you? Integer a is divided by 7, 7q, the remainder is 4, right? So I don't know what q is, but I have some number of multiples of 4. I'm sorry, some numbers of multiples of 7 in there, and then I have a remainder of 4. All right, now they want to know what's happening with the remainder of 5a. So let's just take this true statement right here and multiply it by 5. So I get 35q plus 20. Okay, so now I want to divide it by 7. So I want to pull, so this is too large, right? This remainder has to be smaller than 7. And I want to pull out the multiples of 7 from here, right? Okay, so let's first, I'm going to suggest we break up this 20 into something that can have numbers that I can factor a 7 out. So I'm thinking 14, right, and 6. So I rewrote 20 as 14 plus 6. All right. So now what I want to do is I want to factor out the 7. So I want to find out how many multiples of 7, so I can factor a 7 out of these two terms, right? So I have 5q plus 2. And then here is my remainder of 6. The remainder of 6 is smaller than 7. That's a good thing. So here I have 5a equals 7, and I'm just going to call 5q plus 2 an integer. So I have 7p plus 6. So what is the remainder when 5a is divided by 7? The remainder is 6. All right, so the challenging part, and these first couple are giving you clues, but the challenging part as you move forward is knowing how to break numbers up. So typically, if it starts talking about odd and even, then you want to break it up into odd and evens, right? Or sometimes you want to break it up into using d equal 4. So that means n equal 4k, 4k plus 1, 4k plus 2, 4k plus 3, right? So you don't know how to, first couple here I'm giving you examples, or hints I should say, but as you move forward, you're going to have to kind of play with it like, how do I want to break up the numbers so it'll be useful for me? All right, so the product, show that or prove that the product of any two consecutive integers is even. So since it's talking about even, I'm going to use d equal 2. So there's two types of numbers, right? Two types of numbers. There's n equal 2k and n equal 2k plus 1. So that's how I'm breaking it up, because in the end I want to find even. Okay, so if I want to talk about the product of two consecutive integers, so that means n times n plus 1. And so if I'm using the n equal 2k case, this gives me 2k plus 1. And I can say this is the same thing, just kind of regrouping it, right? 2k plus 1. This shows that it's even, right? Because I've made it a multiple of 2. Okay, so now I need to use the case, right? So this was the case when n equals 2k. Now I need to use the case. What if it's this kind of number when I'm talking about two consecutive integers, n and n plus 1? So I'm replacing n with 2k plus 1, and then I have 2k plus 1 plus 1, right? So this plus 1 is this plus 1. Okay, so 2k plus 1, and then what do I have in here? 2k plus 2. So 2k plus 1, 2 times k plus 1. So I'm just going to put the 2 there. So I have 2k plus 1 times k plus 1, kind of just gathering them together. So I see that this shows that it's even. All right. So let's look at this next one. So when d, show that the product of any 3 consecutive integers is divisible by 3. Okay, so since I'm looking for divisible by 3, I'm giving you a suggestion. That means I want to think of the cases where d is 3. So I've got 3 cases. So I've got n equals 3k, n equals 3k plus 1, and n equals 3k plus 2. So I want to work with these three cases. So 3 consecutive integers, that's going to be n times n plus 1 times n plus 2, right? So I want to show that that quantity is divisible by 3. So let's do it here. So you want to start by always writing down, right, what you're starting with. Then let's substitute in for my n. So 3k, 3k plus 1, 3k plus 2. So what do I want to show? I want to show that it's divisible by 3. So I'm just going to insist that you just kind of just gather them. And you say, look at there, divisible by 3. Divisible by 3. Okay, so now let's use this case. So I've got n times n plus 1 times n plus 2. So now I'm substituting in 3k plus 1, 3k plus 1 plus 1, and then 3k plus 1 plus 2, right? So what does this simplify to? 3k plus 2, and here I get 3k plus 3. Let's factor a 3 out of this. You don't have to have that many steps here. 3k plus 2, and then k plus 1, right? Factored the 3 out, left with this, pulled the 3 here, so this shows it's divisible by 3. All right, last case. So if I start with this type of number, let's see if I've got some room here. I'm going to put it down here. So if I'm using this case, n times n plus 1 times n plus 2, so substituting in 3k plus 2, 3k plus 2 plus 1, 3k plus 2 plus 2. Okay, so I'm going to simplify these guys. 3k plus 3, 3k, whoops, 3k plus 4. Oh, so that should have been broken down. All I need to do, this really turns into a 3k plus 1 again, right? But all I really need to do is show that it's divisible by 3. So I'm going to take this, factor the 3 out. This gives me k plus 1, 3k plus 4. There it is, divisible by 3.